So this is a question from our chemistry textbook, and it's on page 68, question 2.40. And the question is essentially asking, calculate the atomic weight of copper given the following isotopes. Copper 63 at 69.09% with a weight of 62, almost 63 U's, and copper 65 with a 30.91% with a weight of almost 65 units, atomic units. And so if we remember, isotopes for us, isotopes essentially have a different mass than what we see on our periodic table, and that is because we have more neutrons than we normally would see. So if we looked at our periodic table and we have copper, the atomic number is 29, and the weight is 63.55. So when we're looking at our periodic table, what we really need to keep in mind with our atomic mass is that it's relative weight. And the term relative weight refers to two specific things. The first being that the element copper and its atomic weight of 63.55 is relative to the different types of carbon or copper we have in our atmosphere. And so those different types refer to isotopes. So on average, this is the weight that we do see, and we will hopefully get this atomic weight when we calculate with using the isotopes. The second component where relative weight comes in is it's relative to other elements that we do see. And typically what we say when we say relative to other elements, we're talking about carbon, because carbon is one of our highest abundance elements on this planet. So in terms of calculating the atomic weight of copper, what we're going to do here is we're going to use the isotopes given to us, so copper 63 and copper 65, and we're going to use the percentage that we see of them in the atmosphere and in the environment. So copper 63, we have about 69% of copper in our atmosphere, and on the planet around 69% copper 63. Almost 31% of the time we see copper 65. So those weights are different based on the fact that we have a certain massive percentage. So how we're going to set up this question is we're going to use the atomic weights, their percentages, which we'll start with copper 63, so 69.09%, we're going to have that over 100. And the reason why we're going to have that over 100 is because we cannot work with a number in its percent form. The percent sign itself tells us it's a fraction of a whole number, and that whole number is 100. And we're going to multiply that by its actual atomic weight, which is 62.9298 units. And we're going to add that to the other copper, which is copper 65. So again, we're going to have 30.91% over 100, and we're going to multiply that by 64.9278. Okay, so with our calculator, if you know, we have 69.09. Okay, we're essentially moving the decimal place over to the left, or if you want to divide by 100, that's okay. So we get decimal 6909, and we still have it multiplied by 62.9298. And we are going to have 30.91% divided by 100 to give us decimal 3091 multiplied by 64.9278. So this is exactly how we calculate a final grade for the course, using what is called weighted averages. And this is exactly the same principle. So now we're just going to multiply this together, and then we'll multiply this together, and then we will add to get those together. So decimal 6909 times 62.9298 gives us an answer of 43.478198882. And it is important to keep all decimal places. Do not round until your final answer, or else it will throw your values off. So decimal 3091 multiplied by 64 decimal 9278 gives us a total of 20 decimal 0691828. And now we're going to just add these two together, and we get a total of, so 43.478198882 gives us a total of 63.5473818. And so if we're going to consider significant digits, typically we only have 2 decimal places, because as we move into these decimal places here, it becomes less accurate. So our final answer will be 63.55. And if we look actually back to the top, okay, at our periodic table for copper, lo and behold, we do get 63.55 on our periodic table. So this is so we know that we've accurately calculated the atomic weight of copper to be 63.55 given these two isotopes, because you should, given the isotopes, get the exact same number as shown on your periodic table. So I hope this helps explain isotopes, and this is an excellent question to be practicing and understanding for your test.